Hello, my name is Pablo Valero. I will briefly introduce this project, the project of the course Embedded System from the Southern Denmark University. The project focuses on the implementation of a hardware-accelerated steering prediction system, combining an offline trained convolutional neural networks, or AI, and FPGA acceleration. The following recordings show how the dataset was created in the laboratory back in Denmark in the SDU, and then some demonstrations of the final system operating under different conditions. Hope you enjoy the video. Okay, welcome to this new chapter. As you probably know, we have all the frames of the video we made in the laboratory. This dataset, which is the frames classified manually depending on right, left, or straight on. Okay, and we are gonna now demonstrate that the system is technically correct, even if the camera in real life was not working. Okay, we have all the frames in the micro SD card now directly on the board. And now let's demonstrate this. Okay, here in Vitis, yes, this is, for example, this image, the 001100, okay, and here in Vitis, 001100, okay, that's correct. I have already built the project, so let's run as, okay. And now what we hope is the prediction, but now an accurate prediction based on the training on the neural network in the board. Okay, now it's done. If we go back to Visual Studio Code, we have that the prediction is to turn right, and this is the prediction, the number. We had some troubles with the floats, but this is 07. So it was here 08. It's not perfect in this case, but more or less it has a good tolerance of the prediction based on the result of the board. Let's try with another example. Dataset now turning left. For example, let's take 000734. 000734. Okay.
1 0 more.
00. Oh, thank you. 000734. We save. Now, yes, of course, we have to build the project. Okay, and now let's see if the prediction is accurate with this new example. Okay, apparently it's already good. Turn left, okay, and the prediction is 0.1, and the prediction from here in the manual classification by us, it was 0.1, so the prediction in this case is perfect. Yes, thank you very much, and see you in the next chapter. Hello, well, based on ROS2, we have created one node. The first node is the publisher. In the publisher, we are publishing the topic. This topic is the images from this camera. This camera is connected to the PC, and once we have this, we can create another node. This node is subscribing to the same topic. What happened now? Okay, now we can see in real life. You can see here my hand in the screen. Okay, so if we take the camera in this position, what we are seeing in the screen is our road. So now we have to send these images through UART to the board. Here we have the board, and have the prediction back to the PC of the idea of what has to do the car, the real car, of turning left, turning right, or going straight on. So the idea. Okay, here we have the C code in Vitis, which is already run in the board. as we can see here, we are waiting for the images. Okay, if we go to the terminal here, we have the node publisher. Now we are publishing the images, and in this other node we are gonna subscribe to the same topic, and we're gonna start sending the images from this camera through UART to the board. Okay, and if we go back to Visual Studio, now we are waiting for the images, we are sending the images, and we are receiving back from the board, from the CNN, which is run in the board, the prediction. What's happening here? Here, the real road, we are turning right, okay, and here the result, okay, now it's turning right, but we have tried the same with several images, and the result is not accurate. There are a lot of mistakes depending on the image. Why is that? Because we have trained the neural network with images from another camera in the laboratory with conditions of the perspective of the camera, of the brightness of the room, completely different as the conditions we have now with another camera, with other conditions, directly with the screen. Okay, the conditions are completely different, so the images are completely different, and the neural network cannot work with these different conditions. That's why the results with all the implementation, they are not accurate at all. But wait to the next. Okay, so you've seen that this project illustrates how AI models can be efficiently deployed on embedded platforms, which is the case using hardware-software co-design. Well, for more information, you have the report, and also for further information, you can just contact me. So thank you very much. Thank you for watching. Bye.